Hey, welcome everybody into the Wells Tech Garage. This week we got another German car in here. I'm sorry, they just seem to be breaking down a lot around here. Go figure. So we are looking at a Lien code on here today. But before we get into that, let's go into the t-shirt giveaway question. If it's your first time here, you answer the question in an email, you send me out an email, and you win either a hat or a t-shirt. So Technician A says an engine is lean when the O2 sensor reads a lack of hydrocarbons in the exhaust. Technician B says a lean engine runs cooler because it's getting extra air. Who's correct? Tech A, Tech B, both, or neither? Now you have until midnight tonight to submit an email to me. If it ends up in my inbox after midnight, thanks for trying, but you don't qualify. It has to get to me today by midnight to qualify to win either one of the Wells hats or one of our t-shirts, either gray, blue, or black. So good luck on that. I hope you guys find that to be an interesting question. So let's start out by a Euro brake. Keith says a Euro breakdown, come on. Well, yeah, like I said, go figure. Let's start out first of all by, well, I'm going to start out by saying sorry, I don't have the check engine light on right now because I cleared the code out and it hasn't come back on at this moment. I apologize for that, and I'll get into that a little bit further in the story. But today, guys, I want to talk about this 2007 Audi A3 2.0 turbo FSI motor that's sitting here in the shop today because it took longer to diagnose, and we have diagnosed it, Peter and I have diagnosed it, but it took longer to diagnose than I wanted it to. So I want to share with you guys our process, share with you guys the diagnostics behind it, but then also share with you some of the pitfalls, some of the areas where we got stuck because there's a lack of information or a lack of familiarity or a lack of understanding of the PIDs or maybe scan tool issues, whatever it might be. I want to share that information with you guys so that when you get something like a German car in the shop, you can maybe avoid some of those pitfalls that we ran into. Keith is ready for field trims. Awesome. First of all, let's start with what is a Lien code. This thing had a P2177 code. What exactly does that mean? So if we go out to our repair resources, we're going to use Identifix for this. We type in P2177. That was the code that we had stored. And look at that. There's no suggested fixes. So close up the hood, run it out. We don't know what to do with it, right? Well, guys, it's just a Lien code. A Lien code means what? It means that our oxygen sensor is reading an excess amount of oxygen, right? There is something is happening that the engine is not running to stoichiometric like it wants to, or it's not adjusting, or it is having to adjust to properly run at that stoic level or whatever level it's intending at that point. So this engine is currently, supposedly, running Lien. Now, we don't have much information in here. We do have the VW Audi DTCs, so let's just do a quick Control F for our find box, type in 2177, and we see a system to Lien off of idle bank 1. Well, obviously it's going to be bank 1 because this is a 4-cylinder engine. It only has one bank. It only has one upstream sensor, okay? So V6, V8, you could have bank 1, bank 2, obviously. This is going to only be bank 1. But what's really interesting here, it's system to Lien, what? Off of idle. It's different than what we're used to from the domestic side or even the Asian side of the vehicle manufacturers. We have trimming on this vehicle at idle and off of idle or under load. They call the trims adaptation idle and adaptation partial. Okay, partial is going to be that off-load trimming. Okay, let's take a look at what exactly it looks like on the scan tool. And let's go, now I am in the engine menu. Again, I said I don't have any trouble codes, unfortunately, but let's go live data. And with Volkswagen Audi, you have the option to either read by channel or do advanced measure value. Read by channel is going to get you into it where you're trying to go instantly. So if we go channel 32, that's going to take us right where we need to go in this point. If we do advanced measure value, we're going to see all 300 plus PIDs that are available for this car. that we're going to have to scroll through. So that's where we're going to go right now, because that's most likely, unless you know all the channel numbers, most likely where you're going to go at first. And we're sitting at just above 12 volts. I'm just going to flip the battery charger on quick. Make sure we don't end up with a dead battery halfway through. All right. So currently, key on, engine off. We are sitting at all of these parameters here, okay? So obviously, we're not flowing anything on the mass airflow sensor. Our throttle valve angle is 7.5% is probably throttle closed. Coolant temp looks normal. Intake air temp looks normal. Engine load, kind of weird, 100%. That's kind of weird. Keep scrolling. And I want to get to, like I said, I want to get to number 32. That is going to be, as you can see, we got a lot of PIDs here. But number 32 is going to be where we get into our adaptation. So I'm going to grab adaptation, adaptation, and I'm going to grab this one also. So what we're looking at right here, adaptation idle and adaptation partial, are our long-term fuel trims for idle and for off of idle or under load, okay? So right now, judging by what we're seeing here, we are reading Lien under load, right? Anytime our percentages are above 0, positive percentages, we are running Lien. The vehicle is adding fuel to the extra amount of air that's entering into that engine. So for some reason, this thing is thinking there's more air, potentially, in the engine, so it's adding more fuel. So we could have a breathing issue, we could have a vacuum leak issue, but we're talking under load here. So why under load do we think that there's not a vacuum leak issue? Because under load, especially on a turbocharged engine, we don't have engine vacuum, or we have reduced engine vacuum, or in this case, we have pressure, we have boost in the intake manifold. So is it likely that we have a vacuum leak anytime we're not at idle? Anytime we're trimming, long-term field trims are up at off of idle, at load, under load, at partial, we're probably not looking at a vacuum leak, right? There's a lot of other things that can cause a Lien condition other than a vacuum leak. Even though that's what most people think, you hear the word Lien and right away you think vacuum leak, bad hoses, bad mass airflow, bad low fuel pressure, crack in the air intake snorkel, something like that. But vacuum leaks are going to be the #1 cause, or what people think is the #1 cause of a Lien code. So let's look at the scan tool again. And I want to talk about this Lambda Control B1S1. Lambda Control here is our short-term fuel trim, okay? We will see this percentage scale up and down depending on how the engine is running, whether it is at idle or whether it is at partial or under load. So we will see that. And remember, the goal of fuel trims, the whole point of fuel trimming is to bring this thing back into emission standards. So as our long terms ratchet up, the whole point of long-term trims are to bring the short terms back to 0 or as close to 0 as possible. Your short terms are happy at 0 or as close to there, so long terms will either ratchet up in a Lien condition or ratchet down in a rich condition to bring our short terms back to 0, to make our short terms happy. That's the whole point of long-term fuel trim. It will trim as much as it can, as far as it can, to bring those short terms back to 0. Now there are maximum trim amounts. Like this one will trim up to a positive or negative 25. At that point, we're trimming to the point of, to the end point for long terms. So there, you will see your long terms, and if you have a really bad Lien condition, you'll see your short terms high as well, because it's having to compensate even greater than what the long terms can adapt for. That's why when we're looking at fuel trims, we add short term and long term together. So we're looking at, let's say we're looking at, the battery is boiling. I'm standing in water here. I think that's from the battery. Holy cow. No, the drain is backing up. Wonderful. Well, our drain is backing up. Hopefully, hey Peter, could you make sure we don't have any extension cords running anywhere near where I'm standing? It would suck to get electrocuted in the middle of a live broadcast. Sorry about that, guys, but yeah. Anyways, where was I? Lien condition. Let's start this car up and let's look at where we're sitting right now. Thank you, Peter. All right, so it starts up. And with any sort of fuel trimming, we always have to wait for the oxygen sensors or air-fuel ratio sensors to warm up. So we'll take just a little bit here for our trimming to start happening. Our lambda control right now is sitting at 0, so we'll just take a minute for it to warm up. Those glaciers are finally melting. No, we got a lot of rain here in the last couple days, and for whatever reason, our drains are backing up. So if I have to run away or suddenly cancel the live stream, you guys know why. I'm sorry about that, but hopefully that's not the case. So this engine was cold. We saw it sitting at coolant temp about 80 degrees, so it's just going to take a minute, and here we go. Our lambda control has started happening. So our short-term trims are changing. We're going, it looks to be running slightly rich right now, so we're pulling fuel back. All right. So right now our adaptation at idle is plus 0.6, seems pretty good to me, and our adaptation at partial 16.8. Now we're not going to see our partial adapt unless this thing is under load. Unfortunately, it's going to be hard to get it under load sitting in here, not on a dyno. All right, so what I did for you guys is I did a data capture of this thing going down the road. Now I just want to stress one thing right now. At this point, technician in the shop is still sitting in the driver's seat. The hood hasn't even been popped yet. We've looked at data and we've understood how the system works. You're less than 5 minutes into this job, right? We know that we have a problem. It looks pretty good at idle right now, but our problem is under load. So at this point, guys, take it out and drive it. Log some data, see what it looks like under load. Before I get to the data log, what are the common things that could cause a Lien condition under load? We already talked that a vacuum leak, probably not the case. Most common that I think, probably mass airflow sensor, a fuel pressure issue, or a metering issue, whether that is air being metered into the engine or the exhaust being measured after combustion. Those are probably the 4 most common things that are affecting our trims at under load. We do need a portable dyno. All right, so I'm going to go ahead and grab the capture that I have here. And as you guys can see, I captured quite a few. But now I did select some PIDs here, so you won't see any of the PIDs that I hadn't selected. So I'm going to start with mass airflow and see if I can change. It won't let me change off of pounds per second for some reason. Whatever, we'll do the conversion, because most of us are used to working in grams per second. So I'm going to grab mass airflow, and I could have grabbed load and RPM and intake and coolant temp, but I wanted to keep the screen as uncluttered as possible. But if you're doing like a VE calculation or something like that, you're going to want those PIDs. We're scrolling through. Right now I'm going to grab boost pressure, because if we have a problem with boost pressure, if we have a problem with the turbo, it's likely we would have a code for a lack of boost, but it's something that I think we can really easily look at and determine if we're close. And the last thing I want to grab is this thing does have a high pressure rail sensor, so high pressure fuel. Let's grab that as well. So just to bring it back one step, this is a direct injected engine. Let me shut it off quick. Since we're looking at captured data, this is a direct injected engine, and it is turbocharged, so we will sit over 1,000 psi in the fuel rail, very commonly under load, and this thing will build boost, should build boost under load. So let's take a look at what I've got captured here. Open up some graphs. Let's turn these up to the ×8 so you can see the most. Now, I'm not going to waste a lot of your time scrolling or scrubbing through these. What I'm really just looking at here is do things match? Do things make sense? Let's start with mass airflow. We're reading at peak. You guys can see the peak on the left side of the graph here. We're reading 0.39 peak pounds per second. So let's head over to the laptop. 0.39 pounds per second, 2 grams per second. Let's bring up the laptop on the screen. So we're just going out to Google, 0.39 pounds per second to grams per second, and we're looking at 176.9. Let's call it 177 grams per second. Is that a good number? 2-liter turbo? I would say that's probably a good number. Judging by other vehicles, bigger displacement engines, other turbo engines, I would say 177 grams per second is a pretty darn good number for this engine. Now, I don't have another engine to go off of here, but am I going to spend a ton of time looking at the mass airflow sensor right now? 177 grams per second at peak, wide open throttle. Actually, if you look at the graph here, I believe this was a second gear pull. I was on an on-ramp. So we're a second gear pull, and then shift, and then third gear. So I got it up to speed at wide open throttle in second gear, shifted, kept it wide open throttle for a few seconds in third gear as well. So we're reading 177 grams per second. It's a lot of air flowing through a 2-liter engine, and that's because we are boosting that engine. You put that in a VE calculator, you're going to be over 100% efficiency because it's a turbocharged engine, okay? So is the mass airflow sensor a problem? Could be intermittently, maybe. But in this test, I don't know that I would say the mass airflow sensor isn't a problem and never will be, but I would put this further down on my list at this point. Right now, I'm going to move on to something else. Let's look at boost pressure. This is the pressure that's inside of the intake manifold. Or actually, this is the pressure sensor that's sitting in the tube before the throttle body. But either way, it is pressure in the system. This is boost. And as you can see, actual and specified look really good, right? At this point on the left side where we're wide open throttle, we're reading 1850 millibar. So again, we go back out here for a conversion, 1850 millibar to PSI. For us people in the US, I know you people in Europe and stuff understand this stuff, but apparently we're boosting this engine to about 26, almost 27 PSI. Sounds like a lot, but again, is this our problem? Is this causing our Lien condition? Our specified and our actual are right in line with each other. Probably not an issue. Are we actually reading 27 PSI? Hang on a sec, I'll get to that. So probably not an issue. Our boost pressure is following in line with our specified. Now let's look at specified and actual for rail pressure. We're looking at high pressure fuel here. By the way, newer cars love that we can compare PIDs like this. It makes our diagnosis just a little bit faster because you got to remember, all we're doing is sitting in the driver's seat right now, haven't even popped the hood. And our rail pressure looks to be right in line with each other. They're following each other nicely. I'm happy with this. I don't think we have a problem with the turbo building boost. I don't think we have a problem with high pressure fuel. And I don't think we have a problem with the mass airflow sensor. Could they be issues? Yes, they could be issues intermittently. You could have a flake of rust plugging up the fuel line or something like that every 37th day when you go over railroad tracks on the way to grandma's house. Sure. What we're trying to do right now is determine a list, a procedure that we're not wasting time, right? Because I know for a fact that I wasted time on this engine. Let me go over one of the factors here where I wasted time. Well, Peter and I wasted time, but I'll take the blame for it. Let's look at boost pressure. All right. So boost pressure on here was, if I remember correctly, we're going to do read by channel. I believe it was 115. And look at that, I have looked up 115 before. So, I'm not going to do the Jeopardy theme this time, Glenn, if you're in here. Dan wants everything in metric. If only I understood metric like I do PSI. Man, whatever. Anyways, boost pressure, actual and specified. You guys see a problem here? Key on, engine off. We're reading 290 millibar for specified, so that's what the engine or the computer wants, and we're reading 980 millibar actual. What does that mean? Well, what is 980 millibar? 980 millibar to PSI. 14.2 PSI. What does that sound like? We've dealt with that number a lot, right? Is it possible that our boost pressure sensor is an absolute style sensor that is reading atmospheric pressure on it right now? Key on, engine off. We don't have pressure in this thing because everything is off. We don't have 980 millibar. We don't have 15 psi of boost going through this engine right now with the key on, engine off. What we're measuring is atmospheric pressure. So again, I asked the question, are we really reading 27 psi boost? Probably not. Let's take a little bit off of that. Maybe that 14 off of that. Do we take the absolute value off of that? So maybe we're reading 13, 14 psi of boost. That sounds a little bit more normal for this engine, especially because if I remember right, no, this thing doesn't have a boost gauge, does it? But on a lot of cars, I've seen boost gauges from the factory go up to about 20 psi. To think that we're hitting 27 on a factory Audi A3, unlikely. But to think that we're hitting 13, 14, probably. It was a warm day, it was a humid day. It's definitely possible. So don't get burned by this, okay? Peter and I spent some time investigating this sensor. We scoped the sensor. We looked at the data PIDs. We checked powers and grounds, thinking that we had a skewed sensor because 980 millibar in comparison to 290, it's about a 10 psi difference, okay? But what we're seeing here is something maybe that I don't exactly fully understand. The scan tool maybe is misinterpreting. Maybe for whatever reason the ECM says that it's supposed to be a 290 millibar, but it's not causing a boost code. It's not causing any issue. I chalk this up to be a scan tool or maybe a coding discrepancy. I don't know. It seems normal to me for 980 millibar at idle. I don't know if anybody else can confirm that. For those of you that work on Audis more often, but I think that's what we're seeing here with this boost pressure. So again, I asked the question, is boost an issue on this engine? Is our turbo an issue? Do we have issues with that? Probably not, right? Again, don't take it off your list of possibilities, but move it to the bottom, right? Now what's next? We've looked at high pressure fuel. We've looked at mass airflow. We've looked at boost. We've done all the easy stuff. None of the easy stuff fixed the car. Slam the hood down, back it out, tell somebody else to fix it, right? What if the car is lying to us? You know, what if the problem isn't only under load? Is that possible? Our long-term trim at idle looked okay, but what if the problem isn't only under load? Now, again, it's possible at this point you haven't even popped the hood on the car. You're still sitting in the driver's seat. What else can you do to see if this problem is occurring right now? What about a code clear? When you clear the codes on this car, and most cars, it resets your long-term fuel trim. So now that adaptation that the vehicle's made to get those short terms happy is now back at 0. All right? So we reset that. What is the car going to do now? What's going to happen now? Well, it's going to start to trim again. So let's clear trouble codes. And I do have a trouble code in here because I did unplug the mass airflow sensor, but I'm going to go ahead and clear that. And this was from setting up the class. All right, clear codes. No fault detected, wonderful. So again, we're just sitting in the car right now, haven't done anything besides hook our scan tool up and go for a test drive. Advanced measure value. Let's scroll it down, and I should have just selected 32. But I think we miss out on 33 at that point. I don't think I have the option to select multiple measuring blocks. But let's grab these 3 PIDs. Let's do a show. And let's just do a graph merge. So we'll look at them all. It's kind of messy. Can we unmerge our graphs? Maybe, maybe not. How do I? There's got to be a way to unmerge the graphs after you click graph merge, right? Well, whatever. Doesn't really make a difference at this point. So what I'm going to do now, you guys can see that our adaptation is 0, both idle and partial or under load. Let's start this thing up and see how it runs. I think we're safe now. A little bit of water on the floor, but we're safe, I think. All right. All right, again, it's going to take a minute for it to start doing something. This kind of bugs me. All right, so we're starting to trim. Hey, what are you guys seeing? I wish this graph wasn't so messy. I'm sorry that I hit the graph merge button, but look at our control. Lambda control. Look at our short-term fuel trim. What are we seeing? We're at idle. This car is idling. I'm not under load. I'm not under the fault that this car claims that it has. What do we see? We see a lean condition, right? We see positive fuel trims at idle. Weird, right? Maybe. Could be weird. I don't know. Whatever you guys think it is. I think it's weird. Why is our short-term idle trim not higher than it is? If we're reading a positive 17, positive 21 at idle after we clear the codes, why is our adaptation at idle not higher? Again, I don't know. Is it a scan tool issue? Is it a coding issue inside the PCM? I don't know. But this looks to me like what? A lean condition at idle on a Volkswagen or Audi. Looks like a vacuum issue, right? Vacuum leak. I said it before. Lean conditions at idle. Most commonly, vacuum leaks. So, for those of you that work on the 2.0 FSI very often, what is the number one source of a vacuum leak on this engine right here? Oh, and before, I know like Oz just mentioned the Autel scan tool. Before you guys go hating on Autel or hating on any scan tool, I want to mention one quick little factor. Autel, Launch, both pull the exact same codes, the exact same data on this vehicle. Everything looks the same. The snap-on tool, our Veris, that you don't see on the table right now, it's sitting in the cabinet. Same thing we ran into with the Audi TT. Didn't give us the data we wanted. We had maybe 15 PIDs at the most, or 300 PIDs with these two tools. I'd be using the Launch today if I was able to hook it into our video switcher so you guys could see it full screen. Unfortunately, it just doesn't look good for me to hold this thing and say, hey, look. But this tool did the job just as the Autel tool did. They work fantastic on this vehicle. Snap-on, not so much. So keep that in mind. Now, guys, look at, please bring up the fuel trims full screen again. What are we seeing now? We're seeing adaptation, right? Our long-term fuel trims at idle have increased 3.3%. What are we seeing now on our short term? Near zero, right? What the heck is going on here? Why is this so strange compared to what we're used to? If we see a positive 20, positive 25 short term on a domestic vehicle or an Asian vehicle, very common to see that start to ratchet down as our long terms ratchet up. Or yeah, short terms ratchet down, long terms ratchet up, right? So if we're positive 20 short term, I would expect to see probably positive 20 long term. It makes sense, right? I don't know why again, but for some reason it seems like this car scales fuel trims differently long term in comparison to short term. So our short term was positive 20-ish. Our long term now, 3.8. That's almost a 4 to 5 times difference in short term to long term. So even though we're not throwing a code for fuel trim issue at idle, even though we're not thinking that we had a vacuum leak in the beginning, this is starting to look like a vacuum leak, like we have a lean condition at idle, okay? So what do? What's next? Well, I think a good visual inspection, right? Give this thing a quick look over. At this point, we're out of the vehicle now, right? We got to pop the hood. We've determined, let's just recap really quickly. We've determined a couple things. One, high pressure fuel seems okay. Sorry, let me get one more data PID for you guys. I almost forgot this one. One more little tidbit of good information here. I want to grab, let's scroll through here. What I'm looking for is, all right, let's bring this up on the screen, thank you. What I'm looking for is somewhere around the middle here, there is a fuel pressure duty cycle or command percentage. And unfortunately, I don't remember the number on it. So bear with me here as I scroll. Current fuel pressure, 67 PSI. That's about normal on these from what I understand. But right here, sorry, not there, here. Electric fuel pump 1, 2. Let's go like that. We'll hit show. We'll scroll it. And I didn't click the right one. Let's go back. Let's click the one I tried to click. And there we go. Electric fuel pump, 38%. Think of this as how hard the electric fuel pump is working, okay? Let me turn the car off quick. So at idle, on an engine that's idling, how hard do you want your low pressure fuel pump to be working? Probably not that hard, right? At idle, how much fuel does an engine take? Not that much. So if our low pressure pump is working incredibly hard to keep up, to feed the high pressure pump that's sitting under the hood, could that be an issue for a Lien condition? If it's having a hard time at idle, let's say, I've heard a number, 60%, somebody said, is where you have to start worrying. I don't know if that's true. I found nothing published by Audi at all. For those of you that work on these vehicles more, is that 60% number something where you have to start worrying? At idle, 60% or higher, I've been told, is a bad value. That is one of those values that you need to look into. You need to diagnose either a restriction in the fuel system or a failing fuel pump, okay? There's something that's causing that pump to work harder than it is intended to at idle. I've heard 30 to 40, even at the most 50% being a good amount of percentage, or the fuel pump working to be good for low pressure fuel. And then obviously that will jump up once we start demanding more pressure. Once this thing's under load and we need that high pressure to go up and we use more volume, that percentage will go up. But it's a good first test and a quick test to look at to see, is my low pressure pump a problem? Probably not if you're down around that 30, 40% mark, okay? All right. Okay, so Lien condition, no high pressure fuel issue, or it doesn't seem like a high pressure fuel issue, doesn't seem like a boost issue, doesn't seem like a mass airflow sensor issue. One quick tidbit of information, guys, a little secret I'll let you in on. This thing was running worse when I initially got it, all right? It's running better now than it did when I initially got it. And unfortunately, I performed a repair that I can't undo. I pulled the mass airflow sensor out, took some mass airflow sensor cleaner. Remember that video where I used carb cleaner? Never do that. Took mass airflow sensor cleaner and I sprayed this sensor. Now in that video, guys, I also mentioned my view and my feedback on what I thought cleaning the mass airflow sensor did, but I did clean it on this engine and I noticed a change, okay? Is the car fixed? We looked at live data right now. Is it fixed? No. Is it better? Yes. We cleaned the mass airflow and it is better, but it's not fixed, okay? Now in this case, the mass airflow sensor is no longer a problem, right? 177 grams per second is pretty darn good. I'm not worried about the mass airflow sensor at this point. I would suggest to my customer, I would say, hey, I cleaned your sensor. It's not a permanent fix. Do you want to get a new sensor? But there's more wrong with this car still, okay? We're not done yet. Mass airflow sensor was a problem. It made this thing run worse, but it did not fix it when I cleaned it. It only made it better, okay? So keep that in mind. You clean the sensor, it gets better, but it's not fixed yet, okay? So in this car, I'm going to suggest to the customer to replace the mass airflow sensor because in my opinion, that is the only way to get this guy back to its normal operating condition. You saw those microscope shots that I had of that one that we took out of, it was a GM. I think it might have been out of the GTO, I'm not sure. But after cleaning, it does not fix it. It only makes it work for a little bit longer. The coating, the non-stick coating, has been beat up by sand and all that stuff after all those years that it's no longer functioning as well as it can, and it will fail again soon. So again, I will sell a mass airflow sensor on this job. I'm missing my screwdriver over here. Let's see if I can get this clip out. Of course not. By the way, there's got to be a secret to these connectors. I don't know. Somebody, if there's a secret to these, let me know, but I just take a screwdriver very lightly, and it's just enough to pop the tab and then pull the connector off. But somebody knows a secret on there, you let me know. All right, Glenn, you're getting ahead of me here. Glenn just suggested smoke test time. Yeah, why not, right? We're looking for a vacuum leak. Start with a visual inspection, of course, right? You want to start visual. Look at 2 minutes. Look over the engine, make sure that it looks okay. Because remember, any air entering into the engine, sorry, Paul, I keep messing you up. Any air that's entering into the engine after the mass airflow sensor isn't being measured by the mass airflow sensor. So now we're getting extra air into our cylinder. We're not giving it enough fuel. The combustion ratio is off, and we have a lean condition. So that's a vacuum leak in a nutshell. Let's yank this cover off the top and hopefully not break any of this plastic. All right. So I mentioned before, what is the most common source of, I use a pick. What is the most common source of vacuum leaks on this FSI 2-liter? Well, we're looking for common issues. Let's go back out here. Let's go home. And you can go ahead and, thank you. Let's just go Lien. Do, 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 do. So now we're getting a common hit, right? So throw a crankcase pressure regulating valve at it, slam the hood, run it out, and it's good to go, right? Let's look into this a little bit more. Now somewhere here, oh, it's not in this one. There is a TSB, and I should have had this prepared for you guys to show you this TSB. Unfortunately, I did not. This might be it. Now remember, guys, I did not have this code, this 2187, which would be a lean code at idle. I had the 2177 lean code under load. So this is talking about a failed crankcase pressure regulating valve. There is a TSB that talks about an updated design here. So what is it about these PCV systems on this engine that are unique? Well, first of all, the PCV system will keep this engine under a slight vacuum, okay? If you pop the hood on your engine and you have a lean code and you try to take your oil cap off with it idling, if you can pull your oil cap off, I don't want to say you don't have an issue, but it's less likely you have an issue. When these things fail, when this PCV system fails on here, it's very common to put direct intake manifold vacuum onto the crankcase. All right? So you have manifold vacuum holding this cap down tight against here, okay? That is typically how these fail. Now this one is not the case. All right? This one does have the new design valve on here, but it has not failed. And actually, I did replace this part. All right, I did not replace it for the lean code, but I did replace our PCV valve on here. The reason why is this car was using oil. This car was going through about a quart of oil a month, 1,000 miles. Quart of oil, 1,000 miles is what he told me. This is the PCV valve on here. And if you look under the hood here, we have this giant vacuum hose, right? This guy right here, directly to intake manifold vacuum going into our PCV valve here. So if this diaphragm inside of here fails, that's how we get direct vacuum on our crankcase. But that's not the case with this one. We did not have that issue. The issue that we had was this is like a check valve. It should be able to flow that partial amount of vacuum into the crankcase, but it should not be able to flow pressure. And what I found, if we smoke tested this thing, or if you blow through it and put pressure on it on that side, you should not be able to blow through it. You should not be able to smoke through this thing. If you can, what do you think is going to happen? Remember, this is an engine that runs not only under vacuum in the intake manifold, but what? Boost, right? Pressure inside of the intake manifold. So now we take pressure up this hose, and we just flooded our crankcase here with PSI of boost. Whatever we're boosting directly from the intake manifold being blown into our crankcase. What do you think that does for oil consumption? probably increases it, right? So that's why I replaced the Pcv valve. It did not have any effect on our Lien condition whatsoever, and it was not giving us the common issue where you can't remove the gas cap, the oil filler cap. Let's just do one quick thing here with this thing idling now. I do have the mass airflow disconnected, but this thing is nice enough that it will still trim at idle with the mass disconnected. So we're going to go back in here, and I'm going to grab 32 and 33 again. It's already 11:40. Holy cow. I've been talking a lot. Got a lot to cover yet. All right, so we're going to grab these again. Now I want to show you what's normal on here. All right, watch this. See that? Can we get a shot under the hood? See what I did? Dipstick's in my hand. Hear the engine note change? All right, that's normal. Again, this crankcase should be under a slight amount of vacuum at idle. All right, and when I say slight, it's roughly that 1 inch of vacuum. Let's pull this out. Throw the old vacuum gauge in, and as you guys can hopefully see, we should be at roughly, if we bring up, there you go. So this is 5, and you can see we're nowhere even close to there, okay? We're at 1 inch of vacuum, which is what this thing should be. All right, if you had the issue, the Pcv issue, that is common on these engines, you would be pulling probably a lot more than that. Okay, so this one does not have that issue. So now that we talked about the most common issue on the 2.0 FSI, let's talk about what do we do next. So it's not the most common issue. It's not anything else that we've looked at, so now we slam the hood and run it out, right? But Glenn brought up before, like I said, he was getting a little bit ahead, smoke testing. Let's smoke test the intake manifold, right? We're looking for vacuum leaks. A vacuum leak is air entering into the engine somewhere. So let's try and find that. Somewhere we're getting air, potentially getting air into this engine. Let's smoke test it and find out maybe where exactly that's coming from. So I'm using our bigger smoke machine, guys. You can use an Evap smoke machine for this. It's just going to take a little bit longer. This smoke machine I'm going to pressurize up to about the 5 psi mark on here, which will help us to it'll just go a little bit faster. So I'm going to pull off the big old hose here that's going into the intake manifold from the Pcv and apply smoke. But before we do that, we want to plug off the inlet side of the turbo, because we will, as we smoke test this thing, we will get smoke pouring out of the inlet side of the turbo. So I'm just going to yank this thing off. I already removed the clamp. There's normally a clamp down on this end, which can be a bugger to get off. I didn't feel like doing it live. So I removed that clamp so that you guys didn't have to see me struggle. And I'm just taking a yellow cap here, and I'm going to plug our inlet into the turbo, and that's not the right cap. Let's try this one. And that's not the right one either. Maybe this is the right one. There we go. All right, so I plugged the inlet to our turbo. So now we should be able to smoke test this thing and look for smoke coming from somewhere. Like I always suggest, always make sure that you have smoke coming out of here before you stick it in the port or whatever you're doing, because you could spend a long time looking for smoke on a system that's not creating smoke. If you run out of oil, run out of oil in your smoke machine, it's bad news. I don't know if you guys can see it. Yeah, there you go. So we got smoke. Let's hook it up here and see what happens. So we're feeding about 5 psi into the system. Hi, Jeff is here. I am late. Oh, VW vacuum leak, never. Yeah. Glenn, you can't be offering up suggestions like that. All right, so we blew our cap out of our intake to the turbo. Let's see if we can push that cap in there a little further. Maybe I'll have to bring our pressure down a little bit. All right, we're down to about 4 psi now. And at this point, you'd want to fancy dancy flashlight, whatever you got. If you got UV smoke or something, grab that. But I don't see any smoke coming out here, guys. Nothing obvious, nothing leaking. Get a little bit out of the crankcase. Yeah, there's some smoke in the crankcase. So somehow the intake manifold is connected to the crankcase right now. Well, we'll have to get that later. That is now underneath the vehicle. But, okay. To the point here, I can turn this off. I didn't see anything obvious. I didn't see any smoke leaking out of anywhere that tells me that we have a vacuum leak. But what's something that we forgot to check? Something that we knew, there we go, Richard's on it. Evap Solenoid, right? Purge Solenoid, N80. We replaced one last time on the Audi TT because it was leaking. Is it possible this one's leaking? Sure is. Let's turn off our flow here. And I'm going to just grab the Purge Solenoid right here. Sorry, my head's in the way. And there goes my clamp, of course. But right here's our Purge Solenoid. All right. Intake manifold on this side, the evap system on this side. So when this thing is not being turned on, we should not be able to have any vacuum on this side, right? So if we put a vacuum gauge on here, and we start this engine up and idle it, we shouldn't see any vacuum on here. Now, you could also be looking for smoke at this point too, but because I blew my cap out of the turbo inlet, that's going to be kind of hard to do. So we're just going to fire this thing up, and we're going to look at this gauge, make sure that it reads 0. The Purge Solenoid is sealed unless it's turned on, right? And turbo inlet's off, mass airflow sensor's off. This engine's not going to start with this giant vacuum leak right here, so make sure you plug your vacuum leak back up. And let's see what we got. Boy. You guys see that? Again, here's 0. 15, 16. Now, it wasn't instant, all right? Watch. It's not instant. It's not wide open. It's drawing slowly, so we have a slight leak on here, right? Now, it's also possible that the computer's commanding it on, so we want to, again, mess with this stupid connector. Well, I'm not going to mess with the connector live. That's enough headaches messing with those connectors. But I can guarantee you guys that our Purge Solenoid is leaking. Okay? When I smoke tested it earlier and I had the cap in the turbo inlet, I found this thing to be leaking. I saw smoke coming out of it. I was able to get vacuum through it. If I put a vacuum pump on the intake side, it'll draw through the Purge Solenoid. It will not seal. Remember, these will not seal in both directions. You have to be pulling the vacuum from the intake side just like the intake manifold will. And it did not seal up. So, replace the mass airflow sensor or clean it and hope it lasts. Replace the Purge Solenoid, clear the code, slam the hood, run it out. Right? That's what a lot of people would do at this point. We found a source of a vacuum leak. We corrected a running rough, running worse condition in the mass airflow sensor. The car's fixed, right? Is it fixed? Is it actually fixed? So if we put a new Purge Solenoid on here, what is that going to do for our engine? That's going to seal it at idle, right? So why couldn't we do that same thing right now without going to the parts department, without ordering the part and potentially needing more parts afterwards, without even walking to the customer and selling a Purge Solenoid yet? What can we do? We can plug it, either with a hose clamp pliers or a little yellow plug. We can plug this guy off. And by doing that, we've now stopped our source of a vacuum leak. So our fuel trims, in theory, should be perfect. Let's start it back up and see. Parts cannon. And Richard, the vent solenoid isn't going to cause any sort of vacuum leak for us. The vent solenoid is part of the leak detection pump on this system. And this system is normally, well, I think this is a leak detection pump system on this car, but that's going to be a normally vented system. It will be releasing any sort of pressure or vacuum that's inside of the fuel tank, inside of the vapor canister. Will be releasing that out. But it's not connected to the intake manifold. The intake manifold is the front door that's closed until the PCM opens it. The back door in this case does not make a difference. So I'm going to go ahead, I'm going to go back into trouble codes. I'm just going to do a quick clear because I should have a mass airflow sensor code in here again because my MAF is disconnected. I'm going to do a quick clear to reset our trims. By the way, anybody who's using a different scan tool, are you able to clear codes if it doesn't have any codes? I went into OBD2 and into vehicle specific, and if there's no codes stored in the system, it didn't let me clear them out. Anybody else run into that? All right, we're going to go back to our advanced measure channel, go back to sorry, we'll go here. Open up our graphs. All right, looks pretty good, right? Now we fixed our problem, potentially fixed our problem here at idle, right? So car's fixed, I think. But remember our initial code. Our initial code was at P2177, and now I don't find cars lying to me that often anymore when they fail a test. I mean, maybe sometimes, maybe an Audi will lie to you, I don't know, maybe. But when a car flags a code for a failed test, it's usually pretty accurate nowadays. In 2007, I would say, probably. Is it possible that there's more wrong here that's not presenting itself right here? All right, let's bring up that full screen, and I'm going to do something to this car and show you guys something. Everybody caught that? Looks like a Lien condition, right? Anybody know what I just did? Let me specify. I didn't do anything to the car that would be out of the ordinary. I didn't do anything to the car that the driver wouldn't do. I didn't unhook anything. I didn't unplug anything. Any idea what was just done with this car? If you can answer what I just did right there in the comments section right now, I'll give you an auto win on a shirt. Because I tell you, I scratched my head, and Peter and I we have a lot of time into this thing, figuring this thing out. I'll be the first to admit, this car kicked our butts for a little while. It took more, and like I said in the beginning, it took longer to figure out. God, two people got it already. Of course it would be Bob. And Bo, your name doesn't look familiar, but good deal, you guys. Well, these people are way smarter than me. It wasn't something that came to mind for me right away. It's something that's overlooked very often on the modern car. Maybe on older cars, and I don't know how old all of you guys are, but working on older cars maybe saw this a lot more often. But I can't remember the last time I replaced a brake booster because it was leaking vacuum. Especially on a newer car. When is the last time you put a brake booster in because it was leaking vacuum? It's not something that happens very often anymore, right? I do not hear a hiss. I do not. So what would have helped with this? One thing I want to point out, guys, never ever overlook the brake booster in your smoke test. Remember, a smoke test includes what? pressure, right? We put pressure in there. We build pressure inside of here and force it out of the engine or force it out of the intake or whatever under pressure. What happens if you were to put pressure inside of your brake booster? Bad news, right? We only want vacuum inside of our brake booster. So what do we have? Check valve, right? Some sort of valve that doesn't allow pressure into the booster but allows vacuum into the booster. We're testing in a different way than the vehicle is running or the vehicle is testing. Again, we ran into this with Evap. Remember when we were looking at that Alero? You test that system under vacuum, it fails. You test that system under pressure, it never leaks. Check ball in the filler neck. Check valve in the booster. And now it's common on just about every car for a check valve in there. But it's something that can be commonly overlooked. So let's just introducing a brake booster. So I tried my best at some artwork here for you guys to explain how exactly this could be failing. Now I don't have x-ray vision. I cannot see inside of the booster. This is purely speculation at this point, but I know that my booster is causing this engine to run lean when I press the brake pedal. Okay? So, for those of you that don't know brake boosters, we have our intake manifold vacuum connected directly to the booster, right? Through a check valve. I drew it like a diode because it is like a diode. A diode controls electricity in one direction. A check valve does it for vacuum or pressure in one direction. So we allow vacuum to build up. I'm going to draw vacuum in blue. Vacuum to build up. We have a perfectly flowing intake manifold. We got like 17 inches of vacuum sitting in our intake manifold. Drawing in here, we got 17 inches of vacuum in this side. We got this little, I referred to it as a doohickey before. I don't know the name, but there's some sort of flow piece in here. Because if we have vacuum on one side and something other than vacuum on the other side, we have a pressure differential. And this pressure differential creates possibly movement. We have a spring right here that's intended to keep this diaphragm. Sorry, I should have explained that. We have a diaphragm in the center of our brake booster. And this diaphragm usually has a plate in the middle and then two pieces of rubber on the sides. All right, and this diaphragm moves back and forth. This is a rod mechanically connected. Our foot at our brake pedal on this car is mechanically connected to our master cylinder. So we push down on the brake pedal, we are mechanically connected in some way to the master cylinder. So if we have a problem with the booster, if the engine dies, we still have a physical connection to the brakes. Now this is going to change when we go brake-by-wire on cars, but it's a story for a different day. Vacuum inside of here, all right? This little doohickey, whatever you want to call it, vacuum valve, whatever, it doesn't matter, allows for a pressure equalization inside of the booster when the pedal is not being depressed. So when you're not on the brakes, we allow vacuum on the other side. Okay? So why is it, if I'm saying we have a bad booster, why is it that we're not running lean all the time? Why did I have to go into the car and step on the brake pedal? Let's use, I'll just stick with blue. These little red thingies here that I drew, right here and right here, those are seals. All right? Not like the marine animal, but like the rubber, whatever. It's a seal on there to seal this chamber from atmospheric pressure, right? We have atmospheric pressure all around our brake booster. Everywhere here, on our skin right now, everywhere, we're dealing with atmospheric pressure, right? That 14 point whatever PSI. We're dealing with that all the time. Atmospheric pressure is all around us. Now we have a container sitting here in vacuum that's sealed. What happens when we push the brake pedal? We move a shaft, right? Something moves. We force pressure down here. It moves our shaft. We unseat this whatever. We unseat this piece off of the seals, okay? Now this is an incredibly rudimentary drawing that is probably not actually completely accurate, but the theory behind it is accurate in that we unseat these seals and we allow this atmospheric pressure that's pushing on the outside of our brake booster, we allow that to enter into the brake booster. And it enters in very quickly because we have a difference in here, right? We have vacuum on that side. So vacuum on one side, pressure on the other, it wants to equalize very quickly to atmosphere. So we unseat these, and now, instead of, and I should have represented these differently, they shouldn't be blue. So instead of vacuum inside of this guy now We'll call it positive pressure, or we'll call it atmosphere, whatever you want to call it. We now have atmospheric pressure on this side of the booster, okay? We moved this lever, or this valve in here. We've moved this. When this moved, it's connected to this piece here. This red thing's got a seal on it too. Somehow it's sealing, again, not accurately drawn, but it gets the point across. We seal off our vacuum doohickey. Our little vacuum valve here gets sealed because we don't want vacuum leaking or pressure leaking in to the vacuum side. What does that equal? If we have a bad seal here, what does that mean? If we have a tear in our diaphragm, what does that mean? It means that as we press down on the brake pedal right here, what is allowed to happen? With the brake pedal in its seated position, with these seals doing their job, we allow vacuum in this entire thing. And it's a sealed chamber. It's happy. The engine's happy. It doesn't have an issue. As soon as we open up these seals, we allow that positive pressure to rush into here, and we create positive pressure here. Now we're allowing that positive pressure to leak, right? Let's say our diaphragm is bad. Let's say we got a hole in the diaphragm. Now we're bringing positive pressure into our vacuum side. Where does that positive pressure go? It follows the vacuum, ends up on our intake manifold. What happens when we end up with unmetered air in our intake manifold? Hasn't gone past the mass airflow sensor, gets into our intake manifold, ends up in our cylinders. What do we have? A Lien condition, right? So we could have a problem on this seal here. We could have a problem on our diaphragm. Why? One more thing. Why does it seem to be only when I press the pedal? Well, it could be this seal, but also with rubber, guys. Rubber stretches. Let me ask you this. This is a diaphragm out of a leak detection pump. It's obviously significantly smaller than a brake booster, but it gets the point across. Can you guys currently see the leak in this diaphragm? Sorry, the focus is way off, but can you currently see the leak in the diaphragm? This thing's pretty much at its rest position, and it's happy right now. And do you see the leak? Probably not, right? I can't see it. But what happens when we push the brake pedal? Do you see the leak now? All right, you see the leak? How about now? We stretch the rubber, we stretch the diaphragm, and now a leak problem that wasn't there is suddenly there. Right? So I like this little example to show this because it completely defines our Lien problem. Our Lien problem says it's happening under load. Well, sometimes you're braking when you're under load, right? It's a stick shift car. You're slowing down. Not everybody pops it into neutral when they slow down. The car's still under load then, right? It's sitting 3,000 RPM or whatever as you're coasting off an off-ramp. You didn't put it in neutral. You didn't bring it back to idle, and you're hitting the brakes. You've now put a direct vacuum leak onto this engine by pushing on the brakes, and somehow inside of this booster we are getting direct atmospheric pressure flowing into our intake manifold, creating a leak code. What do you think? If I had a microphone right now, it'd be like, mic drop right there. I don't know. This, doohickey, good technical term. This took a lot longer than I wanted it to diagnose. And it's one thing that I just wanted to bring up to you guys, to never forget about the brake booster. It is a giant vacuum reservoir on our cars that gives us a heck of a lot of issues. Now, let's say this was an automatic. Let's say this car wasn't stick shift. All right? Stick shift car, what's the process? Do most people leave it in gear when they shut off? Sure, they might. Some people put it in neutral and yank the e-brake. Sure. I don't know how you guys drive, but on an automatic car, I believe Audi is this way, like BMW and some of the other Europeans are. You have to go in and you have to press the brake pedal to start the car, right? Could this problem have been found very quickly on an automatic car? What do we know as well, we talked about it just before, check valve, right? Maintains vacuum inside of our booster. So if our check valve is functioning, if our booster is functioning, we should still have some vacuum there. So if you shut the car off, let it sit for a minute, start it back up, you should still have some vacuum assist available to you. Your pedal should not be rock hard. If your pedal's rock hard, you got an issue, right? you've leaked off all of your vacuum, giving you no more power assist. Now in an automatic car, if this thing requires the brake pedal to be on when you start the engine, or to start the engine, it might have been found right away. But being that this thing is stick shift, it's not something, you don't have to go in and touch the brake pedal at all. If the car's in neutral, push the clutch pedal, you're on the e-brake, car's not moving anywhere, you never touch the brake pedal until it's running, until we reapply vacuum to our booster. So this morning, when I drove the car in, I parked the thing on a hill and dropped my kiddo off at daycare, and I didn't pull the e-brake this time. I left it in gear. All right, left it in first gear, and it wasn't a big hill. Don't yell at me for not pulling the e-brake, okay? It was a small hill. It was like whatever, doesn't matter. The car rolled backwards as soon as I pushed the clutch down. My first reaction, hit the brake pedal, right? Brake pedal was rock hard, all right? I had already known at this point that I had a brake booster issue, but it just helped cement it into my head that we have an issue here, and it's something that on an automatic car might not have been overlooked or might have been tested much sooner. On a manual car, it's not something that came to mind right away, okay? So don't ever forget about the brake booster as a source of a vacuum leak, and don't trust the scan tool data. Don't think just because it's only reading a +3, a +4 at idle, that there's not an issue at idle, okay? I think that's about it. So really, to fix this car properly, my suggestion to the customer is going to be 3 things. 1, I would like to replace the mass airflow sensor because I cleaned it and I don't believe it's going to last. I don't like cleaning mass airflow sensors. If the customer is willing, I would like to replace it. 2, replace the purge solenoid. It is leaking. We have confirmed that it's leaking. We confirmed that by plugging it, we were able to get some of our vacuum leak to dissipate. We were able to get our field trims to be happy. 3, it's going to need a brake booster. This is able to come separate of the master cylinder, but that should fix this car right up. And I believe after all of that fun, all of that diag, this 2-liter FSI motor will be fixed. So what do you guys think? How many miles? 125,000 miles. Thanks for coming, Bo. We'll see you next time. As usual, on older cars, don't forget the transmission vacuum modulator. Sure, yeah. Any sort of vacuum source on an older car, vacuum modulator, sure. What about like on a vacuum actuated hubs? Are those directly connected to intake vacuum all the time? Is it possible you could have a hub causing a vacuum leak on like a truck or something, the front hub's engaging with vacuum? Possible. I'm not sure if those are connected to the intake manifold at all times, but something to look at. I just want to scroll up through some comments here and make sure I haven't missed anything. Anybody got any questions, anything that they want to see yet today? I'm pretty much done here, I think. I didn't get flooded out, I didn't get electrocuted, so that was fun. First time the drains have backed up, that's interesting. But anyways, I think, yeah, exactly like that. On Ford's F-150s, they send vacuum directly to the hubs. So, yeah, Kevin, you're exactly on with the Fords. But I'm not sure on those Fords. I'd have to look at a vacuum diagram if those are routed directly back to the manifold or if they have a check valve or a solenoid or something in line, because I know they run a vacuum reservoir underneath, what is it, the air box or the battery? There's a vacuum reservoir for those hubs, and I believe there's also a vacuum solenoid somewhere in there. So it's possible that the leak, the vacuum leak, the Lien code, only happens when that solenoid's turned on. Could be. Stranger things have happened. So just because it's a strange fix doesn't mean that it's strange because of the 4 circles on the grill right there. This fault could have happened to any car, any car whatsoever. It doesn't even have to be a turbo motor. And our process, while we had some pitfalls in there with some data and some questions on that, really wasn't any different than diagnosing a Ford or a GM or a Chrysler or a Honda or whatever. A Lien code is a Lien code. A rich code is a rich code. An evap code is an evap code. Understand the reason it's setting, why it's setting, the code set criteria. It's always good to look at. Look for TSBs. Look for recalls. Identifix it. Look to see if there's anything common that can maybe, again, don't shotgun apart at it because Identifix says so, but test that because it's a common failure. Test that first. At least then you can check that off your list. Try to do the easy things first. Just because it's an Audi, granted we spent a lot of time on it, it's not really that much different than anything else. There are pitfalls to avoid, but other than that, it's just a car. It's just an engine. Suck, squeeze, bang, blow, monitoring the in, monitoring the out. It's not any different. So don't get turned away just because it's something that you're not used to seeing every day because it's German or if you're, if you don't work on Asian vehicles, whatever. They're all the same. Granted, they don't all give you the information, but the operation is very similar. So, instead of connecting everything back up to show a customer, could a hand pump with a gauge be used to show the customer where air is coming in at? Sure, Neil, you can use a hand pump with a gauge at any point. In fact, I've proved many Purge solenoids using a hand pump. Mr. Customer, here's your Purge solenoid. Here's a vacuum pump. This is just like your intake manifold. Connect it up, start pumping. It's leaking. It's supposed to seal. You need a Purge solenoid. That's an easy sale, and sometimes it's nice to just show your customer that. Then they believe you. They trust you. So yes, always show your work and test things multiple ways if you can. I almost forgot. There is one more thing, guys, that I want to do here. I almost forgot. You guys should have reminded me. I almost just closed it out and forgot to show you guys this cool little bit. So like I said, testing two ways. I pumped the pedal. We saw a change in our fuel trims, right? Once we get some smoke flowing here, I'm going to smoke the booster. All right, I want you guys to watch a couple things here. Let's see if I can get this big thing up on the table. Like so. Let me, I'm going to bring up the camera, flip you guys around, and like so. Okay, Paul, could you bring up the scan tool in the corner? So as you guys can see, we are currently flowing into our booster, and it's a slight leak. Our ball here is slightly leaking. Now if we go into the vehicle, missing my flashlight, I think it might be plugged in. Problem? So I guess real quick, bring up underhood. You'll see, oh, sorry. I'm messing with you now. No smoke on this side, okay? But, oh, let me get out of the way. I don't know if you guys can catch it yet, but let me. I can't really see what's happening. I hope you guys can see this, but I'm slightly pushing on the brake pedal. I've broken the seal to let atmospheric pressure into the pressure side of the booster, and I can't see my camera. Oh yeah, you guys can see that. Look at that. Pretty cool, huh? So now that we've filled our customer's car with lovely, nasty smelling smoke, I'd say that's a confirmed fix. Oh, thank you, Paul. One other thing. Watch the ball on our smoke machine as I'm pushing down on the pedal. Maybe. You guys can see it'll build pressure. A leak might actually be getting worse. That ball's not dropping down very far. But as this thing builds pressure, it'll actually build pressure inside because our seals on the atmospheric side aren't that bad. But as I push the pedal, you see the ball go up there. And if I let go of the pedal, the ball will start to travel back down as it fills the reservoir. Push the pedal, goes back up. Ball goes down as it's filling the reservoir. Push the pedal. We get our leak. Perfect. So, I think that'll do it. I think we can turn this guy back off. Any questions, any issues, anything that anybody wants to see while we have all the cameras hooked up and that kind of thing. I am going to try to dismantle the booster when it comes out, unless there's a significant core charge on it. But I am going to try to dismantle it because I'm curious. I want to know what's leaking in here. What's causing this thing to leak? My curiosity needs to be satisfied. So once I get there, I will post some pictures up either on Facebook, or maybe I'll include them in a video coming up or something. I don't know. Look for them out on either social media or on YouTube for that kind of thing. That just means you guys have to make sure you're following all of our social media, right? If you want to see this stuff, you got to go out there, Facebook, LinkedIn, Instagram, and Twitter. We are on all of them. Just search for Wells Vehicle Electronics. All right. Solid wants to see me replace it. I do not have the new booster yet. I have to, actually, we just finished up with the diagnosis on this thing yesterday. So I still have to confirm with the customer and order up the parts. So it won't be fixed for probably another week or so. Yes, thank you, Glenn. Smash that thumbs up button if you guys are liking what you're seeing, and please subscribe if you haven't already. And there's like a little bell icon somewhere. Click on that if you want to get reminded every time we go live or we publish a new video. It should like send you an email or send you an alert or something like that. So make sure to click on that. How about next month's webinar as a follow-up? Sure, I could probably include some pictures, maybe even the actual booster in next month's webinar. Glenn's going to resubscribe. Was there anybody that had any questions? Anything else that you'd like to see while I still have everything set up? Speak now or forever hold your peace. Moral of the story, if the booster is leaking and you're getting a Lien condition, tell the customer to stop using the brake. There you go. I'm sure that's going to go over well. Well, it does have an emergency brake, right? Good luck with that one. I think it's better to do it by sections, eliminating sections by clamping hoses. True, Luis, that's maybe not a bad idea to really break down the system, and by doing that, you really have to have an understanding of the system to what to clamp off when you're smoking. Sure, it's not a bad idea to do that. Tannerite. The date of next month's live stream, we will be going live, tentatively speaking, on June 7th. So 1 month from today, we will be going live, June 7th. Not sure what we're going to be covering yet. Got a couple ideas. One, something maybe to do with some VVT issues. One, something maybe to do with some compression issues. Don't know yet. We'll see. We'll see what the month holds, but we should have something cool and fun and interesting to learn about next month. How much is the labor for shop going to be on that booster? I don't know what the labor is going to be on it yet, Luis. I haven't, or Lewis, I'm not sure. I haven't even looked up the labor time on it yet. It will be summer next time, Glenn. God, I'm not wearing a bikini though. Thanks anyway. All right, I'm going to wrap it up then, guys, unless anybody chimes in at this very moment. Thank you, everybody, for watching. I hope you found this helpful and learned from our, I don't want to call them mistakes, but just I don't think misunderstanding is the right word either. I think unfamiliarity is probably the perfect word to put into this. I don't work on Audis every day. We just happen to have 2 in a row here for the classes, but it's not something I work on every day. I mostly work on domestics and Asians. So when I get something like this, and there is unfamiliarities there that have to be looked at. I mean, just the fact that we're using an aftermarket scan tool instead of the Volkswagen Audi scan tool. Maybe that would aid in some of this. Maybe there's things that tool can do to help make this faster. I don't know. I deal with what I have, and you guys too, right? I mean, if you don't work on Volkswagen Audis every day, I highly doubt that you have that tool. But an aftermarket tool can get it done. So didn't need any special training, didn't need any special tools, just a little bit of time to figure out how the system works and general knowledge of the way an engine runs. And you guys should have that already, working on the domestic cars or working on the Asian cars or whatever. It should be pretty straightforward. So that'll be it. Thank you everybody for watching. We'll see you on June 7th. If you haven't signed up for Auto Mechanica yet, make sure to look into that. That's coming up in August down in Atlanta. Peter and I are both signed up for that to be headed down there. So I hope to see everybody who's going. I hope to see you all there. And until June 7th, guys, have a great week. Enjoy your weekend, and happy wrenching, everyone. Thank you.